kit and caboodle, as they say. Oh, by the way, there is something called, let's do this real quick. There is something called mprobit. But look how much slower it is. So we saw how fast mlogit worked. And remember the reason logit was developed in the first place. Probit came out, the reason they developed logit in the first place was for computational speed. Again, this was in the early days of computers where computer time was expensive, and they wanted to speed up the process. So, here we've got, here's an illustration of the difference between the computational speed of a probit and the logit in the multinomial sense. And we could be here for the rest of the evening, and this thing's gonna work slowly. So that's the difference between mprobit and mlogit. But there is a thing called mprobit. The reason we don't use it is 1, speed, and 2 is that it's much more computationally intense, and therefore it's also much more sensitive. So sometimes it just won't converge, and you'll just get if it ever stops, you'll just get a failure to converge. All right, so this looks like, again, the thing about margins is you got to be really specific to what you're doing. So we're going to analyze the effects of Keebler's own promotional effects, which means we want to set everything else equal to 0. We're going to evaluate it over the price of Keebler from 0 to $2, which is what we've been doing. And then we'll graph it. And we get what we expect. Shifted out, it looks like display has the smallest effect, and then feature and display appear to have similar effects. And we're going to, we know how to test, so we can test for whether or not feature and display and feature are statistically different from each other, as well as whether any of these are statistically different. But again, let's not lose sight of the original paper on promotions that we looked at, which was by that guy, that talked about if you just include dummies, you're going to get these parallel shifts. And that's really what this represents, just as it did with our linear demand curves. These are parallel shifts out of the nonlinear demand curves. We should interact them to see if the slope is different. So here is the model with the double hashtag, price multiplied by all the individual effects. So we're going to get the dummy and the interaction effects. The problem is, as it says, this won't converge after quite a few iterations. So should we interact them? Absolutely. I wrote a paper about that, on what that means. It means that the behavior of people that purchase on promotion is different than that of people that buy off promotion. So it's not really a statistical argument. To me, it's a behavioral argument. So theoretically, we should do it. The problem is practically that we can't, at least not using this process. So it doesn't work. Now, we shouldn't give up, because as we showed in that paper from 2011, that's kind of important. So it does make a difference. So what we can do is if we're only going to analyze these own promotion effects one at a time, then let's try interacting these one at a time. So remember, all this stuff is being set to 0 anyways. So the only ones we're going to interact are the Keebler with the Keebler promotional activities with its own price, and see if that converges. And it does. So the problem was we're just kind of overwhelming, the process is overwhelming for Stata. And we are getting, so here's Keebler. We are able to get the dummies, which are the ones right below price, and then the interactions, which are below that. And then we just have the dummies for our other promotional activities, which is fine because we're not evaluating them anyways. We're going to set them equal to 0. So it really doesn't matter. Now the question is, does it really matter if we interact them or not? Well, let's see. Let's graph it with the interactions and then graph it without, and then compare the two using our graph combine function that we love so much. So get some weirdness, but clearly the graphs are different. Specifically with feature and display, we get a much bigger effect, which we'd expect when we have two promotional activities going on simultaneously than we get with display. But even display looks like it's shifted out a little bit more. And the nice thing, or the telling thing that we see is that feature, what do you think that means? We're literally getting 0. And then we got this little spike up here like that. I mean, what do you think that means? Does it mean anything? Well, what it probably means is that there's no data here. That's why these are 0. So this is something we wouldn't have been able to observe with, oh, obviously you can't observe there. Remember, by using just the dummies, all we're doing is allowing those curves to shift out in a parallel fashion. By including the interactions, we're allowing differences in behavior across these three functions, these nonlinear deviant functions. And, but it also tells us that for, at least for feature, we don't really have a whole lot of data there. Which is why we constructed these, which is why we might want to look into the data a little bit further. So one, yes, it does matter that we interact. We don't have to interact all of them. It just means we have to change our interactions as we evaluate Keebler. When we evaluate Nabisco, we'll take off the interactions for Keebler and put them on for Nabisco, and so on and so on and so on. So, but again, it's not that big of a deal to move those two little pound signs. But it does tell us something about the data. And we might want to kind of investigate that a little bit further in terms of just looking at how often is each type of promotion occur. And as we saw, sample size can be a concern. And then the second one is, sample size is always a concern. And the second question is, we interacted price and promotion because, as we saw in the original paper by me, that when firms promote, they often simultaneously lower price. And if they're doing that, then the return on promotion is going to be overestimated. So we might want to look at those two things. We probably always want to look at these two things. So the first one is, how often is each promotional type done? And we kind of did this in the last assignment, where you're looking at some histograms. Feature was the one that we were getting the weird results for, and feature is the one that has the fewest observations. Now 54 isn't tiny. Remember the central limit theorem? We need at a minimum of 30 to kind of get regression to work and to get it trustworthy, but 54 is relatively small. So yeah, we are talking about a small sample size. And remember, we're talking about 54 occurrences of Keebler being on feature, and that doesn't necessarily mean, as we saw, that those feature promotional activities occurred throughout all prices. We saw where there were no prices available, so we weren't able to estimate that. The other thing that we can do, however, is kind of compare this to what we're not seeing is, these are literally the number of times that we engage in each kind of these promotional activities, but we don't see the number of times that when we didn't promote at all. So how often is it for us to promote? We don't really know. So what we want to see is the times that we don't promote at all. To do that, and then we can get the percent obviously. And this just gives us a percent, but this is the percent of times of promotion. So 8%, 2%, 3%, which tells us that it's not on promotion all the time. But what I did was relatively simple. I just constructed a new variable, called it Keebler promo, and I set it equal to 0 when there's no promotion. I set it equal to 1 when we're on display, 2 we're on feature, and 3 we're on feature and display. So all I'm doing is creating a variable so I can construct a different graph, a new graph. And that graph will look like, oops, will look like that. And that's where those percentages kind of hinted that we're really not promoting all that often for crackers. So almost 3,000 observations, sales of crackers, and only 54 times that we engage in feature, 264 for display and 86 for the combined. So sometimes when we're not getting the graph we want, we need to construct a new variable. And this was a pretty easy solution to that. Yeah, about 8%, and then 1% for feature. So again, a very small number of times for feature. It's not surprising that we got some wacky results for that, because we just don't have a lot of observations for those.
What is feature again?
Feature are things like mailers. So when you get you get the newspaper, or you get your mail, and there's a something that just says buy Keebler, 20% off or something like that. So feature is anything that is outside of the store, whereas display is any kind of display within the store, inside the store. And then again, sometimes we do both. Summary statistics are always going to, not always, are a good way of finding gaps in the data. And in this case, we saw that regression, but if we had done this first, we would have seen, okay, we don't have very many observations for feature, and then we would have been surprised when we got that weird spiky thing. By the way, that weird spiky thing is, the reason you're getting a spike is you've got no data here, so these are all zeros. But this isn't an upward sloping point here. This is just the data ends there. The no data ends there, and the data starts here, and it's, or I'm sorry, the data starts here at $1, and then this is connecting those 2 points. So it's not really a spike, it's just we're going from 0 to positive effects. And by definition, we're a line graph, we're literally connecting the dots. And that's why we're getting that. All right, the other thing is let's examine prices. All right, so we can kind of look at this. Yeah, that's not very good. Let's look at this. And again, these are awkward because we've got 3 tables. We could see that the non-promoted price is $1.13. And it's about the same as we go down, $1.13, $1.13, $1.13. There's some rounding error because the sample size differs. And then we can see that the display price is $1.09, it's less than $1.13. The feature price is $1.07, it's less than $1.13. And the feature and display price is $1.01, and it's less than $1.13. This is awkward, this is a horrible way to I mean, we can construct a table from this, but we should be able to do better than this. On top of that, we don't know if these differences are statistically significant. Is $1.09, for example, when keyboard on display, is $1.09 statistically less than $1.13? Well, how do we always test things? We run regressions. So here I'm just regressing the price of Keebler on its promotional activities. Remember, those are dummies, so in essence, what we're going to get is that $1.13, and we're using the full sample, so we get that $1.13 is the non-promoted price. And when it's on display, it's 3 cents less, and that's statistically significant. When it's on feature, it's 5 cents less, and that's statistically significant. And when it's on feature and display, it's 12 cents less, which is statistically significant. We can get a table of those prices by just using our margins command. Over our promotional activities. And these values should be the same as the values above. So 000 is the constant when it's off promotion, and it's $1.13, 2919, and so on. So here we have a table of results. And are these differences statistically significant? From the regression, we know yes, but here are results there. And essentially what we're doing is doing a t-test to see if these dummies are statistically significant. All right, visual, and we can use a graph, box plot. And again, notice I used, let's see, box price. I used that variable that I created. And there's a reason why I created that variable. I couldn't get these graphs to look decent any other way. Tried combining graph combine, I did that 25 different ways. I was simply unhappy with the looks of the graph. Then it finally hit me, just construct your own variable. If you don't have a variable that you want, construct your own variable, and now we've got this side-by-side comparison of those prices. And we can see that the promoted prices, for the most part, are, the distribution of promoted prices, for the most part, are less than that of the non-promoted prices. So, similar to wine, we know that crackers, like wine producers, like wine sellers, I should say, are lowering the price when they promote. So you can get those confounding effects, which means we can do some kind of decomposition of some sort, if we wanted to. Which would be awesome. Think about that. A Quayle decomposition on a multinomial logit. Just that. Like music to your ears. It's like Stairway to Heaven or something, but better.
Kind of.
Kind of better.
No, they asked.
The live version, right? Yeah. I like the box plots better than these. These are, I just like the box plots better than these. These are nice, but, all right. Test for statistical significance. Let's rerun our logit because our last regression, remember that any test will be based on the last regression, but the last regression was to look for differences in prices. So let's rerun our multi-hemming logit. Let's see, what is this? We can test the dummies to see if, let's see, if they're equal, if they're all equal to each other. And that's what that equal means. So we get a small chi-squared statistic. So this is the null hypothesis is that all of our promotional activities are equal to each other. Let's just have the interactions. Yes. So the null hypothesis is that all of our promotional dummies are equal to each other. We can't reject it. We got a small chi-squared statistic, a small p-value. I'm sorry, small chi-squared statistic, right around 2, a large p-value. We want our p-value to be as small as possible so we can reject the null hypothesis. So here we fail to reject that. All of the promotional activities are equal. Somewhat strange, but I think we'll be able to answer that within the next week or so. Let's see, this is a test of the slopes, which are the interactions. Similar results. Even though it looks like those slopes were different, they're not statistically different from each other. Again, something interesting that we probably want to investigate. We might be able to solve. Let's see, what are these? These are basically testing to see if all of them are equal to 0 in the equation 1, which is the Keebler equation. Again, failed to reject. So what we're getting is, the results we're getting are that our promotional effects are not that effective despite the fact that we got a graph that appears to show positive effects of promotion. So again, something problematic, but we'll probably have to figure out a way to investigate that. What are we doing here? I'm evaluating this at, it says $1, but that says 50 cents. So this is at 50 cents. Let's see, this, I don't even know what the command was. Was this margins or was it marginal effects? Was it dy dx? No, this is a predicted outcome. Predicted outcome when Keebler is 50 cents, everything else is set to 0. So let's see, when Keebler is 50 cents, probability of choosing Keebler off promotion is 63%. When it's on feature, it's going to be something really, really small. When it's on, does that make sense? That feature? When it's on feature, so the probability of choosing Keebler when it's 50 cents is 63%, which is pretty high. But when it's on feature, when this is 1, you get this really tiny number, which is essentially 0. Does that make any sense? Does it make sense?
We don't have data, so.
Yeah, exactly. So that's the part where this is 0. Remember, this is feature, and this is literally 0. So at 50 cents, the probability of choosing Keebler according to the model, which doesn't have any data to make that prediction, is 0. So it makes sense given that the data limitations. And the graph kind of conveys that. So if this was me, and I was going to present this, I wouldn't show feature at all. I would just say there's not enough data to evaluate feature. Because then trying to explain this little kink and all that stuff is going to end up doing more harm than good. Just leave it out and say there's not enough data, so we left out feature for Keebler. It's that simple. But our marginal effects were consistent with our graph, which is consistent with our kind of summary statistics that we just don't have enough data for to evaluate feature at that specific price. All right, this is Nabisco. I'm going to generate that same thing for Nabisco, that same Nabisco promo variable so that we can construct the graphs and see if we have any potential small sample problems. Our small sample was 52 for feature. Here we don't have that problem. Our smallest sample is 125. And so it doesn't look like we're going to run into the same problem that we had with Keebler. And that's percent. Let's look at the prices. Is Nabisco behaving like everybody else in that are they lowering prices when they promote? So on average, the non-promoted price of Nabisco is $1.08. When it's on display, it's less than a penny less, but that difference is not statistically significant. When it's on feature, it's about 5 cents less. And that difference is statistically significant. And when it's on feature and display, it's about 12 cents less, and that difference is statistically significant. So when it's on display, which is here, the prices are, is that it? This is display is the middle one. $1.08, yeah. So if you look at these two, they're about the same. $1.09 versus 108. The difference in prices is not statistically significant according to our regression. So it looks like they are, for the most part, following kind of convention of retail consumer packaged goods in that when they promote, they also lower the price. Although the display price is not statistically less than, it's less than, but not statistically less than the non-promoted price. But feature and display, again, the same thing. And again, this was a pretty big contribution to the whole literature of retail analytics. So, all right, so now we can run the multinomial logic. And let's see, this is for is going to be for, I think we already showed it's going to make a difference, so. The no interactions. Again, these should be parallel shifts. And it looks like we got the effects display, then feature and display. But we know those don't include interactions. So we're going to include the interactions. And again, as I said, we can't run all of them. We already saw that. But I turned the interactions off for Keebler and turned them on for Nabisco. Since everything else is going to be set to 0 anyways, it doesn't really, it's not going to make any difference. So rerun those. Look at that graph and see if they look different to us. That is awesome. That's a huge difference. This is why that's such a great paper. Again, I don't know how many times I've said that, but I'm sure you'll count on video. Look at the difference between those two graphs. It's huge. Look at, and not just that, think of the ramifications of the difference between these two graphs. If we ran that first multinomial logit with just the dummies, it appears that we get positive effects of promotion, and they're pretty similar throughout the price range. Right? Isn't that what that's saying? When we promote, we increase the probability of purchasing Nabisco, and again, the results are going to, most of the main results are in that middle 80–90% of the nonlinear demand curve. But it looks like we're going to have similar, so it looks like we would have similar promotional effects if we promoted at 75% versus 75 cents, I'm sorry, 75 cents versus $1.25. If we look at the top panel, it looks like we would have similar promotional effects. Probably going to differ a little bit because these are, they are converging to 0 and 1, but pretty similar. But what does this bottom graph tell us? What does the bottom graph tell us? Remember, the average price of Nabisco was about $1. When we promote at a price above its average price, what happens?
There's a more significant effective promotion.
Which is, one more time?
There's a bigger effect from promotion.
So when we promote and the price is above average,
Oh, there's a lower effect,
Promotion.
less of an effect.
not just less of an effect,
Ineffective.
not just ineffective,
Negative effect.
negative effect. Yeah, it's a negative effect. Remember the whole point of the promotion paper, brilliant paper, was that consumers have reference prices. They know when things are a good deal and when things aren't a good deal, right? So when we promote and we have a price higher than average, we're really advertising that this is not a good deal. We're trying to say it's a good deal, but we're saying it's not a very good deal. That's a big deal because it's telling us that promotion can have counter negative effects unless we combine it with the price reduction. Now, when we do combine it with the price reduction, we know that creates kind of an overestimate of